d minus 3 to the power of 4 is equals to 7 to the power of 4. We have to find the value of d. Without further delay, let us begin. Solution. Let's get down the question first. D minus 3 to the power of 4 is equals to 7 to the power of 4. This left hand side could be written as d minus 3 all squared times 2 equal to 7 to the power of 4 can also be written as 7 to the power of 2 times 2. This means that. Now, let us move this right hand side to the left side. So doing that, we have d minus 3 all squared times 2 minus 7 squared times 2 equal to 0. At this stage, let us recall this formula. It is called derivative of 2 square, which is given by a square minus b square is equal to a plus b times a minus b. Take note of this identity, very important. Now, applying this identity to this left hand side, we are going to have d minus 3 all squared plus, what is b? B is 7 square, so we have 7 square, put them in brackets, times d minus 3 all squared minus, what is b? B is 7 square, everything equal to 0. Let's continue. This means that if you expand this very well, d minus 3 all squared, we are going to have d square minus 60 plus 9 plus, what is 7 squared? That is 49 times, expanding this also very well, you're gonna have d square minus 6d plus 9 minus, what is 7 square? That is 49. Close the brackets, equal to 0. Let's continue. This means that we have d square minus 6d plus 9 plus 49, that is 58, times d square minus 6d. Now, 9 minus 49, that is negative 40, equal to 0. Let's continue. This implies that d square minus 6d plus 58 is equal to 0, or d square minus 6d minus 40 is equal to 0. What we have to do now is to solve each of these quadratic equations. So let's take it one by one. Let's consider this guy first. We have d square minus 6d plus 58 equal to 0. This can be solved using quadratic formula, which is straightforward. So using quadratic formula, d equal to minus b plus or minus the square root of b square minus 4 times a times c, all divided by 2a. From this equation, it is obvious our a is equals to 1, coefficient of this square, b is equals to negative 6, and c is equals to 58. So what we have to do now, plug in all these values into this right hand side. So we have d equal to minus, what is b? B is negative 6. We have negative 6 plus or minus square root of b square, that will be negative 6 all squared, minus 4 into our a is 1, y c is 58. So we have into 1 into 58, all divided by 2. A is 1. So we have 2 into 1. Let's continue. D is equal to minus times minus 6, that is 6 plus or minus square root of minus 6 all squared, that is simply 36, minus 4 times 1 times 58, that is 232. Confirm that using your calculator. Divided by 2 times 1, that is 2. Let's continue. So we have D equal to 6 plus or minus square root of 36 minus 232, that is negative 196, all divided by 2. Let's continue. We have D equal to 6 plus or minus. We can rewrite this square root of negative 196 as square root of negative 1 times square root of 196, all divided by 2. Let's continue. So we have D equal to 6 plus or minus. But don't forget, from the complex number, we know that square root of negative 1 is equals to I. So let's replace this guy with I. So we have I. And what is square root of 196? That is 14. So we have times 14. Let's put it that way. All divided by 2. That is D is equals to 6 plus or minus I times 14. That is 14I divided by 2. D is equal to, it is possible I can factor out 2 from this numerator. So 7I, this is plus, all divided by 2. Clearly, 2 cancels 2. We are left with 3 plus or minus 7I. This means that D is equal to 3 plus 7I, or D is equals to 3 minus 7I. Now, next thing for us to do is to solve the other quadratic equation, which is this. So let's quickly solve it. We have D square minus 6D minus 40 is equal to 0. You will observe that this quadratic equation is factorizable. So let's factorize it. D square minus 6D could be written as minus 10D plus 4D minus 40 equal to 0. So let's continue. You will notice that from these two guys, D is common. So that will be D into D minus 10. Also, we can factor out 4 from these two guys. That will be plus 4 into D minus 10 equal to 0. This implies that what is common? D minus 10 is common. We can pull it out. So we have D minus 10 times D plus 4. D plus 4 equal to 0. This means that D minus 10 is equal to 0, or D plus 4 is equal to 0. Clearly, from this line, D is equals to 10, or from this line also, D is equals to minus 4. So therefore, all the solutions that we have for this algebra problem are the first one. Let's call this the first and second because they are real solutions. D equals to 10. Let's call it D1. D2, let's call this, okay, let's represent this as D2. D2 equals to negative 4. And the other solution that we first obtained, let me show you. We have 3 plus 7i and 3 minus 7i. So let's call them D3 and D4 respectively. D3 is equals to 3 plus 7i, while D4 is equal to 3 minus 7i. So these are all the solutions for this algebra problem. We have two two real solutions, 10 and negative 4, and two complex solutions, 3 plus 7i and 3 minus 7i.